Okay, so now we've got a football, and it's asked what minimum impulse must be imparted to a football of mass 0.405 kilograms to have a horizontal range of 39 meters. Okay, so we have to kick it such that it goes at some velocity and some angle to get out to 39 meters. And it asks what minimum impulse. So our impulse is delta P, which is F delta T. So our delta P is PF minus PI. Assuming it starts from rest, then that will be 0. So it's just our final momentum. So what final momentum must we give this football? And remember that momentum is mass times our velocity. Now in this case, I've called this VI up here, but I guess that's our VF in retrospect. So now we can figure out what velocity it needs to have to cover this 39 meters. So first of all, if we have our VF, this is the Y component and the X component, and there's our theta. So we have some VF cos theta is our VFX, and our VF sine theta is our VFY. Now, if we look in just the X direction, we have all the forces come out to be 0, so then our acceleration is 0. And so then our X, using our kinematic equations, plus V naught X T, and we don't need to worry about acceleration, and our X naught is going to be 0. So our V naught X T is just our XF, or our V naught X is just XF over T. Okay, so now we can look at our Y direction and see that there is acceleration. It's going to be just minus G. So we have YF is equal to Y naught plus V naught YT plus 1/2 AT squared. So that's going to be 0. And in fact, when it returns back to the Earth, that's going to be 0 as well. So our V naught Y is equal to minus 1/2 AT. So then our T is minus 2 V naught Y over A. And as A is minus G, then we can say that T is 2 V naught Y over G. And we know that that our V naught Y is our VF sine theta from above. So then this is 2 VF sine theta over G. And now we can use this time in our V naught X expression above. So our V naught X is our xf over t. So it's xf over 2 vf sine theta over g, which is xf g over 2 vf sine theta. Now our v naught x is vf cos theta, and so that equals xf g over 2 vf sine theta. We can now rearrange this to say that vf squared is equal to xf g over 2 sine theta cos theta. Now, this is a trig expression, so sine of 2 theta is equal to 2 sine theta cos theta. So then this is xf g over sine of 2 theta. And now we want to find our minimum impulse, so our minimum velocity that we need to impart to the football. So our distance is fixed at 39 meters. Our g is a constant. So the only thing we can really minimize is our sine 2 theta, or our 1 over sine 2 theta. So this will be a minimum when this is a maximum. All right, because if this gets any smaller, then this needs to get bigger. So sine 2 theta, but sine can only be between minus 1 and 1, so sine of 2 theta is a 1 at maximum. So then 2 theta equals 90 degrees, so theta equals 45 degrees. So if this equals 1, then our Vf squared is equal to 39 meters times 9.8 meters per second squared. So our Vf is 19.55 meters per second. Okay, so now our impulse, our minimum impulse is delta P, which is equal to just our PF as we said. And so it's our mass times our velocity, which is 0.405 kilograms times our 19.55 meters per second, which comes out to be 7.92 kilograms meters per second. Okay, so then it asks, so that's the first part. So there's our minimum impulse. And now, assuming that contact with the football is maintained as it moves 16 centimeters, estimate the time and average force. So our delta P is F delta T. But also, so we're given distance, so that always makes me think of potential energy. So delta U is minus F delta X. But recall that delta KE is minus delta U, so that just equals F delta X. Our delta KE is going to be just 1/2 m VF squared. And so then that equals our F delta X. And it's just that because our initial velocity is 0. So then our force is 1/2 m VF squared over delta X. So 1/2 0.405 kilograms times our velocity that we solved for, so 19.55 meters per second squared, all over our delta X, which is 0.16 meters. So that's 16 centimeters in meters. And so this comes out to be 483.725 newtons. So that's our average force. And then again, delta P is F delta T. So our delta T is our delta P over F. Our delta P was 7.92 kilograms meters per second. And our force that we just solved for was 483.725 newtons. And this comes out to be 0.0164 seconds. And so then there's our force and our time. All right, so checking through the solution here, the impulse is 7.92 Newton seconds or kilogram meters per second. We get a time of contact of 0.0164 seconds and a force of 484 newtons or 483.7. So that looks good.